Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. We are on chapter 11, that is the organic chemistry, and our topic for today is the condensed structural formula. So, before moving towards our main topic, let's have a quick recap of our previous lecture. In our previous lecture, we read about the general characteristics of the organic compounds. Let's quickly revise these characteristics. First one is that of occurrence. Occurrence means that where these organic compounds are mostly found. In nature, these organic compounds are present in all the living beings, whether they are animals, whether they are plants, and they are also present in the fossil fuel. What are the fossil fuel? The fossil fuel are the fuels that are derived from the dead remains of the plants and animals. So we read that the fossil fuel like coal, petroleum, and natural gas also contain organic compounds in them. They are basically the organic compounds. Second, we read about the covalent nature of the organic compounds, that in all the organic compounds, atoms form a bond with each other by sharing the pair of electrons. So, since they are sharing the pair of electron, this means that they have covalent bond in between them. So, therefore, all the organic compounds are covalent in nature. We read about the composition of organic compound. We read that the organic compounds are the derivatives of hydrocarbons. Hydrocarbons, as the name says, that they are made up of carbon and the hydrogen elements. Um, in addition to these elements, other elements are also present. We read about them as well. Those elements are oxygen, nitrogen, sulfur, phosphorus, halogens, and the metal ions. Then we read about the melting and boiling points for all the organic compounds. We read that the organic compounds are generally volatile in nature. They are converted into gaseous form if they are left open in a laboratory. So therefore they have the low melting and boiling points. We read about the solubility for all the organic compounds. We know that the organic compounds are generally of two kinds, polar and the non-polar. Polar compounds have the partial positive and partial negative charges, dipoles, because of the difference in the electronegativity between the two atoms. So all the polar organic compounds will be soluble in polar solvents, and mm, we read that all the non-polar organic compounds will be soluble in the non-polar solvents. For the polar solvents, we had an example like ethanol and the methanol, and for the non-polar solvents, we had the example like ether and the carbon disulfide or benzene. Then we read about the fact that some of the organic compounds show similarity in the behaviors. So therefore, they were classified in a single homologous series. So since there are large number of organic compounds that have been discovered, so in order to study them properly, it was better that we should classify them into few classes of compounds. Now these classes of compounds were made on the basis of the common group of atoms present in those organic compounds. Each class was considered as a single homologous series, and all the organic compounds that were present in a single homologous series have the closely related properties. Then we read about the reaction that the organic compounds are less stable and than the inorganic compounds, and since they have the covalent bonding, therefore their reaction rates are often slow. You will observe later in your upcoming lectures or in the first year or second year classes that for all the organic reactions we generally use the conditions like increased temperature or increased pressure, or we use the catalyst in order to increase the reaction rate. Why? Because these organic reactions are very slow because of the covalent bonding present in the organic compounds. So now moving towards our main topic, we will first revise certain concepts that we have read in our previous classes. What is molecular formula? Now, a molecular formula is a formula that describes the exact number and the type of atoms in a single molecule of compound. and these elements are represented by their chemical symbols. For example, the chemical symbol for sodium is Na, chemical symbol for carbon is C, chemical symbol for hydrogen is H. So in the molecular formula, all the atoms are represented with the help of their chemical symbols. The number of atoms of each element present in each molecule is shown as subscript following that element's symbol. For example, we have the molecular formula of glucose as C6H12O6. Now, this molecular formula tells that there are 6 number of carbon atoms, 12 number of hydrogen atom, and 6 number of oxygen atom. So molecular formula tells us that what kind of atoms are present in a compound and how many atoms of each element are present in a compound. So there are some examples of the molecular formula of different compounds. For glucose, the molecular formula is C6H12O6. For butane, it is C4H10, and for octane, it is C8H18. Now, what is structural formula, and why do we need to write the structural formula for different organic compounds? Some compounds have the same molecular formula, but they have totally different properties, and we have read it in the previous lectures that those compounds having the same molecular formula but different properties or arrangement of atoms in the space are called as isomers. So since there is a possibility that two different compounds may have the same molecular formula, so in order to easily access the property of a single compound, we need to look into the structural formula of that compound as well. For example, this difference in property is basically because of the different structural formula. For example, here you may see these two examples. In these two examples, the molecular formula is the same, that is C4H10. Now here you have a butane and here you have a 2-methyl propane. Now these two compounds are isomers to each other. This is the structural formula for N-butane. This is the structural formula for isobutane. Now, if you look at the properties of these two compounds, then you will notice that these two compounds have different properties. For example, the boiling point of butane is minus 0.5 degrees C, while the boiling point of this isobutane is minus 11.6. Density of butane is 0.00244 gram per ml, and the density for isobutane is 0.00247 gram per ml. So why these two compounds showed different properties? It was because of the different arrangement of atoms in the space. So molecular formula does not tell us about the arrangement of atoms in the space. It only tells us about the type and the number of atoms present in a compound. Similarly, you may also notice that here these two compounds, ethanol and dimethyl ether, have the same molecular formula, that is C2H6O. Now if you look at the properties, there is a considerable difference in properties between these two compounds. Boiling point for ethanol is 78.5 degrees C, whereas the boiling point of dimethyl ether is minus 25 degrees C. Density for ethanol is 0.789, whereas the density for dimethyl ether is 0.00195. Now you may access from these figures, though these compounds have the same molecular formula, but they are showing different properties. Why? Because of the different arrangement of atoms in the space. Now, so therefore, for a chemist, it is necessary that he or she also knows about the exact structure formula of that compound if she want to study that compound, because each structure would have different properties associated with it. So structure formula shows how atoms are arranged and bonded together in a molecule or a compound. Here there are certain examples of the compounds with structural formula and molecular formula. First one is about the acetic acid. Now, for acetic acid, we have the molecular formula C2H4O2. C2H4O2. Now, you may see here that this is the structural formula of this organic compound, and this is exactly giving us the clear picture of how the bonds are arranged. There are three hydrogen atoms that are attached to this carbon atom. There is an oxygen atom attached to this carbon atom, and this bond between the carbon and oxygen atom is double bond. Now, oxygen atom is covalently bonded to hydrogen atom as well as the carbon atom on the other side. Now, when you draw the structural formula for any organic compound, you must have to satisfy the valency for each element as well. For example, we know that carbon has a valency 4, hydrogen has valency 1, and the oxygen has valency 2. So this means that carbon would form 4 hydrogen bond, carbon would form 4 bonds, covalent bonds, hydrogen would form 1 covalent bond, oxygen would form 2 covalent bond. So while writing the structural formula, you have to see that whether all the valencies of all the atoms have been satisfied or not. Here, for this carbon atom, how many bonds this carbon atom is forming? 1, 2, 3, 4. For this carbon atom, how many bonds? 1, 2 and 3, because here carbon is bonded to oxygen atom with double bond. So we will count it as 2, 1, 2, 3 and 4. Now for this oxygen atom, 1 and 2. For this hydrogen atom, 1. So in the structural formula, we can access the valency of a certain element. We can access the whether that element is bonded to another element through a single bond or through a double bond or through a triple bond. So these lines are basically representing the covalent bond. If it is a single line, then it would represent the single covalent bond. If it is double lines, then it will represent double covalent bond. If triple lines are present, then it would represent triple bond. Similarly, we have the structural formula for ethyl alcohol, also called as ethanol. Now, in the ethanol, we have CH3, CH2, and OH. Now you may see here in this structure as well that all the valencies of all the elements are completely satisfied. So how to draw a structural formula? There are different ways to draw a structural formula, and these ways are shown here. First one is the electron dot or structural formula. In the electron dot structural formula, the electrons are basically represented with the help of a dot. So these dots are representing the shared electrons between different atoms. Second way to draw the structural formula is line bond structural formula that we will use in our next lectures. This is the most commonly employed way to draw the structural formula, and it is called as line bond structural formula because these small lines are representing the covalent bonds. Third one is the condensed structural formula. This is our main topic for today's lecture. In the condensed structural formula, as you may see that the difference between the line bond structural formula and the condensed structural formula is that all the vertical bonds in the line bond formula have been omitted in the condensed structural formula. We will discuss about it, that how this condensed structural formula is derived from the line bond structural formula. Another way to draw the structural formula is with the help of skeletal structural formula in this way. This means that if you are writing a compound like this, then this means that here CH3 is present and this point shows the CH2 group. This is not the part of your syllabus. You just have to limit yourself to these two ways, line bond structural formula and the condensed structural formula. Rest ways will be discussed in your next classes in your first year or in your second year. So for now, you just have to read about the line bond structural formula and the condensed structural formula. Rest ones are told here just in order to give you a general knowledge that how to identify that this structural formula belongs to which way. So what is a condensed structural formula? Condensed structural formula is a structural formula that uses established abbreviations for the various group of chain. For example, we have a compound, uh, let's say we have propane. All right. Now, this propane has two groups, kinds of groups, CH3, CH2. Now, let me write it another way. I have wrote it in a condensed form. Let's suppose we have propane. In propane, we have 3 carbon atoms. Now, you may see here that this group and this group are same. Why? Because this carbon atom is attached to 3 hydrogen atom and also attached to 1 carbon atom. Now if you see this carbon atom, it is also attached to 3 hydrogen atom and also attached to 1 carbon atom. So these two groups are same. Now these two groups are abbreviated as CH3 while writing the condensed structural formula. So anywhere if you have seen written CH3, then you will know that here the carbon atom is attached to 3 hydrogen atoms. Now if you look at this group, at this carbon atom is different from the rest two because it is attached to 2 carbon atoms and 2 hydrogen atoms. Now in order to represent this group, we use the condensed form, that is CH2. This CH2 is called as methylene. Now anywhere if you have written in the condensed structure formula, if you have seen written in the condensed structure formula CH2, then you will know that this carbon atom is attached to 2 hydrogen atom. So this group of atom is abbreviated as CH2. CH3 is called as methyl, CH2 is called as the methylene. So this is how certain group of atoms in structure formula are condensed in the abbreviations like this. So main chain carbon atom, and in the condensed structure formula, main chain carbon atom and hydrogen atom are arranged in a sequence in which they appear in the naming system. For example, we have a structure formula like this. This is the structure formula for propane. Now for propane, you have first to identify the sequence. What is the sequence? In the sequence, this carbon atom is having 3 hydrogen atoms attached with it. Then in the second place, we got a carbon atom to which 2 hydrogen atoms are attached. And in the third place, we got a carbon atom to which 3 hydrogen atoms are attached. So while abbreviating these group of atoms as CH3 or CH2, we will maintain the sequence of these group of atoms. First, at the first place it was CH3, so we would write CH3. At the second place it was CH2, so we would write CH2. At the third place it was CH3, so we would write CH3. We cannot write it as CH2, CH3, CH3 because this is not a proper sequence. CH2 is present in the middle and both CH3 groups are present at the ends. So while writing the condensed structural formula, it is necessary that we are maintaining the proper sequence of the group of atoms in a linear chain of a compound. So here are some condensed structural formula for these compounds. First one is the methane, second ethane, and third one is the propane. These all three are the hydrocarbons. In all these organic compounds, methane, ethane, and propane, there are two elements, carbon and hydrogens. So the condensed structural formula for methane would be CH4. Condensed structural formula for ethane would be CH3, CH3. The condensed structure formula for propane would be CH3, CH2, CH3. So here you will notice that this is the expanded form of structural formula. In this expanded form of structural formula, you are seeing the equivalent bond between the atoms. But in the condensed form of the structural formula, though you may not see the equivalent bond between the atoms, but you may see the sequence with which how these atoms are attached with each other. Here are some condensed formulae for different organic compounds. For butane, it is CH3, CH2, CH2, CH3. Since there are 4 carbon atoms, so we are writing 4 carbon atoms in the condensed formula as well. In the pentane, we have the molecular formula C5H12. Since there are 5 carbon atoms, so we are writing 5 carbon atoms in the condensed formula as well. For hexane, we have C6H14, so we have 6 carbon atoms. For heptane, 7 carbon atoms. So we are writing 7 carbons in the condensed formula. For octane, we have 8 carbon atoms, so we are writing 8 carbons in the condensed formula. For nonane, there are 9 number of carbon atom, and for decane, there are 10 number of carbon atoms. So this was all for today. We will practice writing this condensed structural formula for different compounds in our upcoming lecture. Thank you for being with me.